Okay, I'm gonna get started because it's 6:30. So welcome everyone for joining us. I am Karen Greenhouse. I'm going to be your moderator for the evening. And just a quick reminder for those who have not been on our webinars before, we will keep you muted just to ensure the quality of the webinar. So if you have a question, we're going to be using the chat panel. So if you can find the chat panel in your controls and maybe pop it out, that's where if you have any questions, you can write them in there and I will try to answer them. And if I can't answer them, I will pause Amy and ask her to show something or answer them there. So that's our plan for the evening. And Amy Chow is going to be our presenter. So I am going to introduce ourselves first and then we'll get started. So I'm Karen Greenhouse. I am a consultant for Casio. This is going on my 6th year of that. And I'm also a professor at Drexel University, where I teach in the Math Master's program. And I've been a teacher for 30 plus years, high school, middle school, administrator, you name it. So I am excited about math. And so I love Casio, and I can't wait to see what Amy is going to do. So Amy, I'm going to let Amy introduce herself.
Thank you, Karen. My name is Amy Chow, and I am the Training and Product Manager in Casio's Education Department. My primary responsibilities, as you can see on the screen, are coordinating workshops for schools, districts, and conferences, and then also working closely with our development team on calculator updates and improvements. And I also manage a group of consultants. Karen's among them as well. And then also work on creation and editing of our calculator resources. So tonight we are going to be taking a look at the 9750 G2, which I'm going to show you guys. And I am using let me exit out of this, using the emulator software. So if you are not familiar with Casio at all, or if you have maybe the hardware, we also have software available. We sell these at using a 1 year or 3 year license. You can purchase them individually, or you can purchase them in bulk for like a school or district. But this one is for the 9750 G2. Additionally, with Casio, all our graphing calculators have the same button layout, and so essentially the same functionality. The display will just look a little bit differently as you're alternating between the calculators. So you'll see later on, as we're looking at some specific activities, sometimes our activities are written for other graphing calculator models of ours, but you can use them interchangeably in the classroom because the content is all, something that you can use with either or. So before we get started, I'm going to actually make this screen a little bit bigger so it's a little bit easier to see. So it does look a little funny, but this helps you guys see the screen a little bit better. So what we want to start off with doing is just graphing basic inequalities. So the first thing I'm going to do, if you're not familiar with Casio, is we start off with an icon menu system. So you can use the arrow keys here to navigate through the different options. And so I'm going to go to graph, which is on this calculator icon number 3. Another way to get to each of these different icons is to actually type in the number that you see or letter that you see in the bottom right-hand corner. So it doesn't matter if that icon is highlighted or not. I can easily jump to, let's say, table from here if I wanted to. So I can press 5 and that takes me into the table mode. But if I don't want to do table, I can press the main menu button here, menu, on the second row to get back to my main menu. And so now I'm going to press 3 to go to graph. So as you can see, this is the initial graph editor screen. So this is where you would enter your equations, whether we're talking rectangular, polar, parametric, and then our inequalities. So the first thing we want to do is, right now we notice that we are set up to graph y equals equations. So I'm going to actually go to F3. So this is a little weird just because the buttons don't quite line up. So this is the first tab, so that goes with F1, and this is the second tab, so F2. So I'm going to go to F3 for type. So I'm going to press that button. And this is where I can change the type of graph that I want to have the calculator display. So you'll notice my tabs again have changed along the bottom of my screen. And I don't see any inequalities yet. So I'm going to press F6 for more options. So anytime you see this little arrow screen here, or arrow above F6, that just means you have more options. And now I have my options here. So the first inequality I want to graph is going to be a greater than or equals to. So I'm going to select F3 for that. So you'll notice at the top of my graph screen, the symbol has now changed. And then every single equation that are in every single function that I enter now will be a greater than or equal to inequality. All right, so I'm going to type in y is greater than or equal to x minus 2. Another thing, if you're new to Casio, on the right below the alpha button, on the far left side of the calculator is the x theta t button, and that is your independent variable key. So if you want to type in x plus minus 2, you would use this x. The reason I point that out specifically, because if you start typing with, like, let's say a number for your coefficient, you'll notice that these options populate down here. The options down here actually reference these equations here. So you can put something in y1, and then in y2 you can reference y1. So this works really great with like derivatives and any integrals if you're wanting to graph those. All right, so I have x minus 2, and then in order to store this into the calculator, I'm going to press execute. All right, so there is my graph, my inequality, and now if I want to view that inequality, I'm going to press F6 over here for draw. All right, so that's the basic. You'll notice that our window screen, it's a little bit hard to see on this side, is set up to be rectangular. So if I go to my view window, you'll see that my x min and max are -6 to 6, and my y min and max are -3 to 3. Those are just set up just because we are dealing with a rectangular window. All right, I don't need to change that yet, so I'm going to press exit to go back. And now I'm going to add a second inequality. So I'm going to press exit again. And now under y2, I actually want to type in -x plus 3. So I'm going to type in -x, there we go, plus 3. All right, so I have y1 is greater than or equal to x minus 2, and y2 is greater than or equal to -x plus 3. And now when I draw those two, I get my solution over here. So one thing, the calculator's default to set up, default settings are for the solution only. So that's the only part that will be shaded. In order to change that, depending on what you're looking for, is you would have to go to the setup menu. So to get there, we're going to press Shift Menu, and that takes us to our setup screen. This is where you can change a bunch of different things related to the graphs and related to the other different icons. One example, if I were to arrow up, I can change my display to like fixed or scientific. This is where I can also turn my labels on and off. Add axes, add grids, add coordinates, change my angle if I wanted to or not. So I'm going to arrow back down, and then you'll notice the second line here says inequality type. So right now we're set up for and, or just the solution set where the intersection is. The other option is or, which would be everything shaded. Because we're dealing with a black and white calculator, you'll notice that it doesn't quite shade. It kind of draws extra lines. So I'm going to change it to or just so you guys can see what it looks like. Now that I've changed that, I'm going to press exit and now press draw again. So you can see, yeah, it doesn't, because of the way it previously shaded, I think it would just be too much covered up on the graph. So this, I think, helps students see where all the cross hatches are. So it's kind of neat to see it this way. And definitely
each one is a different direction.
So yeah, so each one is a different, yeah, so it makes it easier to see and makes it easier to differentiate between the two. And then for sure, if we are shading, if our solution set was maybe over here instead, that would show a little bit better. So it's not quite the same type of shading. Definitely if you're dealing with a color graphing calculator, like our CG10 or the CG50 model, you would have, be able to graph in the different colors and then be able to see, our first equation is typically blue and our second equation is typically red. So when they overlap, you can kind of see the purple. And I'll show you one of our activities that kind of shows some of that. So that's the basics of getting set up and getting, graphing an inequality and then also seeing the shading. So I'm going to change it back just because this gets a little bit busy to and. And now I'm going to press exit. And then the second thing I want to show you guys is what you can do. Let's say that this wasn't the right inequality. Let's say this was what the inequality originally was. However, because we had that negative sign, we forgot to, let's say, flip the inequality, right? We divided by a negative number. So if this is not the right inequality, instead of having to go through, delete it, and retype it, we can actually convert it. So this works really well if you have different equations in there already. So this is kind of a second way to graph inequalities. So if I have an inequality or an equation that's already in there and I want to convert it, I'm going to go back to F3 type. And instead of going to F6, you'll see above F5 it says CONV, which is just short for convert. So I'm going to press F5. And now I can take the equation that I have, or inequality, we'll call it a function, the function that I have highlighted on my screen, and I can change it to whatever inequality I want. So let's just change it to, let's do a y is less than, so we can see what that looks like. So that's y F3. So now you'll see that y2 is less than negative x plus 3, right? And now if I go to draw, you'll see that my shading changed because of where the equation, the inequality changed. And so now this is the shaded region.
So Amy, quick question.
Mm-hmm.
The lines themselves don't differ if it's equal or not equal, like if the equal is included or not included. Can you tell?
So I am trying to remember, because I know on some of our other graphing calculators, like on our color graphing calculator,
Yeah.
it does.
It does, yeah.
Because it's easier to see. So let's try another, let's do type. And let's just graph a y is less than. Nope, I did not do that right. Apologies. But the buttons kind of throw me off a little bit. Yeah.
I have such a hard time with it.
Yeah. So let's just do y3 is less than. We'll just do 2.
Do like 5. Do something easy. Yeah.
So it does change. I'm wondering if it's because we converted it.
No, I mean when you draw the line.
Oh, when I draw the line, it should actually.
Okay,
dashed.
so it is. It's just hard to see in the black and the white as it is.
Yeah, I think it's a little bit harder to see.
Dotted versus solid. Okay,
right.
Good.
It is a dotted versus solid. And you'll see on the right side, which is also very interesting. Maybe it's because I converted it and it didn't quite realize it. But that should have also changed because we now have a less than symbol. But thank you for asking that question. It should. That is very weird. That's probably a quirk. So maybe if we try to type it in now, so negative x, what is it, plus 3? Yeah.
Yeah, no.
So I think because the original was, and it is, you can see it's a little dashed.
Yes, dashed. Okay.
Yeah. Converting it kind of messed it up. All right, so that's the basics. And then, something else we can do is, if we had 2 equal to inequalities, so like a less than or equal to or greater than equal to, if we go to F5 GSolve, we can find the intersection point by choosing our inequalities. Don't know, well, it'll show you where the 2 cross, but you can see that here. So just doing GSolve and finding an intersection will still find it for you. But then depending on, which equation you're talking about in this situation.
Right, it may not be a solution.
It may not.
Right.
Right. So that's finding the vertex points. And then another neat thing, because we're starting to talk about linear, or we're actually going to go also into a little bit of linear programming, you can actually also add constraints to these inequalities, and it kind of looks a little neat. So I'm going to, instead of having to maybe create like another equation or inequality for these, so I'm going to actually go in. So I just highlighted Y1 and I use my arrows to arrow over, and I'm going to limit this inequality from, let's say, -2 to 4. So now I'm going to add a comma, which is right here above delete. And in order to add constraints, whether you're talking in an equation or, you know, inequality in actual equals to, you would use the square brackets. So you will see them right above the plus and the minus in yellow. So that means we have to press shift and then the plus sign. And I'm going to now type in -2, comma, and then 4. And now I'm going to close my square bracket.
So the first number is the lower bound?
Lower bound, yes. And then the second number is the upper bound.
And so if you don't have a lower or upper, you just would leave it blank? But
Yes.
The comma. Okay.
Yes. So I can actually, I'll show you that in a little bit too. So we'll just draw this first one here. So you can see it just cuts it off, and then obviously because the solution stops here, it's not going to cut it off here. But we have now cut off at -2. So another thing, so like, as Karen was asking, if we, let's say we had wanted to go from -infinity to, let's do -infinity to -2. So I'm going to go back in and I'm going to leave my left bound blank. So just don't type anything, add a comma, and now I can type in my upper bound at -2. And now when I draw it,
okay,
it stops there.
That's pretty easy.
Yeah, so that's pretty easy. And the same with if we wanted to go to, you know, positive infinity, you would put in your lower bound with the value, put a comma, and then just add the square bracket. So
can you limit the domain? I'm not the range, the Y, or no?
No, I don't think you can limit the range. I think you can only limit the domain.
Okay.
Yeah, because we're dealing with our dependent variable is
right.
Y.
Got it.
So, all right. So that's the basics on inequality graphing. Before we really dive into an activity, are there any questions?
I haven't seen any.
All right. So we have a couple of resources available out there for everyone. We have a series of workbooks, and I'm going to show you guys. And I have all of this typed up in a PDF that I will share at the end in the chat panel. So these are kind of some of the things that we're going to kind of take a look at. But we have workbooks, and then we have our fostering series. And I'm going to show you an activity and an investigation from either one. So the way our workbooks are set up, they are by content level. So we have Algebra 1, Algebra 2, Geometry, Statistics, Pre-Cal, and Calculus. And they are primarily written towards the 9750 G2 and the 9860 G2. So those are both our black and white calculator models. However, like as I mentioned earlier, if you're using one of our color graphing calculators, the button pushing is all the same and the questions are all not necessarily, you know, they're all written just for math, towards math content.
Right.
So you don't have to have that particular model calculator. So with the workbook series, it starts off with like a teacher notes page. Some things that, you know, the objective of the activity, we rewrote these to the NCTM standards just because they were more they're just easier and just more generic, yeah, for us versus having to try to focus on a different set. So that's the first page with some getting started, you know, what's the prior to using this activity, knowledge stuff, ways students can provide evidence learning, and some basic definitions that you might want to talk about or the kids might need to know before. And then after that, it jumps into a how-to section. So this is just basic, essentially what we went through today, you know, how to graph an inequality, how to set it up, what that looks like, talking about the different inequalities you can set up, how to change them. And then we also looked at changing the view windows. as needed, and then finding intersections, which we talked about all of that. So that's, something that you can easily pass out to students or use in the classroom if you're first, getting started with the students. And then we dive into the actual activity. So let's take a look
before
at
you
this.
move on, can I interrupt? I just
Sure.
talking about workbooks, but all of these activities are available as free lessons on Casio's website, which we'll share later.
Yeah, thank you. These are part of a workbook series, but we've broken them all out. And so we've just kind of combined them and set them up, and I'll show you guys where to go for all of that. So this is the activity, and I'm going to actually go ahead and share this activity. But while I do that, I want you guys to take a look at the activity, the first section, and I want to see if we can come up with the 3 different inequalities right here. So the inequality with the constraint on the number of lots, inequality with the constraint on the size of the lots, and then inequality with the constraint on the cost per lot. So while you're looking over that on my screen, I'm going to share this file with you guys so you can download it later.
And she's sharing that in the chat panel if you're wondering what she's talking about. You should see a file show up. There it is.
Yep.
And if you hit download, it just will get downloaded onto your own computer.
All right. Is that enough time? I think we can at least come up with the first inequality.
So if you have the first inequality, if you want to type it in the
yes.
chat panel. Whoa.
Sorry about that. I'm going to try to move this over so I could type next to it.
You should shrink your...
You can shrink my calculator screen now, huh?
No, not your calculator. Well, yeah, but I'm saying you could also shrink your PDF so we can see both at the same time.
True.
Nice background.
Thanks. I did not take it. Unfortunately. But it's very calming and very...
It is. Very nice.
Yes.
Oh, we have one. Tom has...
All right. Thank you, Tom. X plus Y is less than or equal to 150. That's perfect for the number of lots. And let's also take, someone else will help, or if Tom has a second one as well in the third equation.
And you're going to type them in the...
And I'm going to type them in the calculator. So what I'm doing now is I'm actually going through and I'm going to just delete them individually. So I am using my arrow keys, highlighting each individual inequality and typing in delete using the F2. All right, so the first one was less than or equal to. So let me go back and change my type. Go to F6 and I'm going to press F4.
All right, I'm not seeing many.
So one thing we do have to realize, we have to graph all of these in Y is less than or equal to, right? So I know the first equation is X plus Y. So then if we do the quick math, it's going to be, well, we won't rearrange them. So just to make it easier, 150 minus X would be the first one. All right. Tom has the second one. 0.75x plus y is less than or equal to 130. All right, so once again, we have to kind of do a little bit of the math. So one thing I can do is I can actually enter things as a fraction. So it'll look a little bit differently, and I need to include some parentheses here because of the way everything is laid out, because this is more of a linear calculator. So I'm going to type, let's see, so 130. No, this one doesn't require fractions. 130 minus 0.75x. Oh, I missed the point. Now I'll just leave the parentheses in there. And then I had Terry respond to me as well. 30x plus 50y is less than or equal to 6,200. So that's something we can talk about as well. Do we want to leave all those extra zeros, or can we kind of take some of them, divide some by 1,000? Is that going to affect what our solutions look like? So I'm going to go ahead and just leave it all in there for now, and then, that's something you guys can explore as well. So this time we're going to need the parentheses. So parentheses, 66,200,000
I'm impressed you're writing those big numbers.
I know. Minus, and it's going to be 30,000 x. No, wrong x. And that's going to be all over. So you'll see that the fraction symbol is just a little L. So the calculator recognizes that that's going to be a fraction, and I'm going to put in 50,000.
Now, our other calculators, the fraction button actually makes it in standard form, where it will look like a fraction.
Correct. And I'm going to press execute. And so now I have my 3 inequalities. All right, thank you guys very much. So next, the questions then goes into, so what is the largest combination of types of homes that can be built if we're only looking at the number of lots and the size of the lots, if we're only looking at the number of lots and then also at the size of the lots. So now we're going into having to find, the different intersection points. So before we do that, let's actually go through and draw this and then talk about a little bit about, let's see what. All right, so clearly our window is not set up very well, right? So I'm going to press F3 for view window. And this is where we can type in the different things. So one thing we can consider is, or what's our X minimum? Well, how many one-story houses do we want? Can we have a negative amount? So no, we can't, so let's do 0, right? And then we know the max number is 150, so then I'm going to type in 150 for that. And then I'm going to set my scale to, let's do 20. And then I'm
now, are you only going to graph the first 2? Is that your?
I'm going to have all 3 graphed, and then we'll take a look because we have it set up to where it's and. So it will only show us our solution, which is kind of nice. All right, and so we know that the number of houses, 2-story houses can't be below 0. The max, let's say it's possibly going to be, 150 if we didn't sell any 1-story, didn't build any 1-stories. And then we can adjust from there.
Wow.
That's actually pretty close.
Pretty good.
Yeah. And then the other option we can choose to as well is use zoom. So we can see, what it kind of looks like right here a little bit better. But then, that's basically what we want to take a look at. So that's essentially what, one of our linear programming activities. And then there's a ton of other questions that you can explore with your students. And then, we also go into, well, what about profit? What is that going to look like? If we make a profit of, 3,500 on the acres based on the lots, which combination will give us the highest profit? And then sometimes you'll see in some of these activities some extension questions just to pull it a little bit further. You guys are more than welcome to use these activities however you want. They do come in PDF form. So, you might need to, just kind of blank something out or something or cross something out.
So Amy, can you show like how would you find that question number 4 was just the intersection of the first 2, right?
Right.
So
sure.
How would you do that?
So we would want to find where the first 2 inequalities intersected, right? So we know that the first one, the number of lots is in Y1, and then the size of the lots is in Y2. So when I go to GSolve here above F5, and I select intersect, I need to make sure that my equations that I selected are the Y1 and Y2. So you'll see here kind of in the upper left corner, it's kind of flashing. Just because of the location, it's a little bit harder to see, but it's right here on the axis. So that's asking, do I want to select Y1? You'll see in the upper left corner as one of my inequalities. So I'm going to press execute, and then it moves down to Y2. Let's say I didn't want Y2. Let's say we were looking at the number of lots and the cost per lot as our 2 different constraints. So then I would use the arrow again, and then it would go down to Y3. And then I press execute to select that one. And then it gives me my intersection points.
Okay.
And it's kind of neat. You see here the X can be 65, but then Y has to be less than or equal to 85.
Nice.
Yeah. All right. So that's one of the activities that I wanted to talk about tonight. Any questions on this one? And then in the activities themselves, at the very end as well, we do have the solutions here for you guys, and just some, basic, what we would expect the solutions to look like from the students. All right, so I'm done with that activity. The next one I want to take a look at is investigation 6.3. So as I mentioned, we had workbooks, and then we also have fostering, like a fostering series or a fostering book. The fostering books are also broken out by content level. So we have algebra, or we have a middle school one, we have algebra 1, algebra 2, which we call advanced algebra, geometry, statistics, and then we do have one for STEM and music. Is that it?
I think that's it.
Yeah. So these activities, we have a section in the Fostering Algebra or Fostering Algebraic Thinking book, all on linear programming. So linear programming, we know, is using inequalities to, set constraints and boundaries and look at just the feasible region relating to, like a word problem, essentially. So each investigation is set up with like kind of a did you know. The did you know usually relates to the problem itself, not necessarily the exact problem, but just kind of a fun fact, really, as to that you can kind of discuss if you want to. And then it goes into a little blurb. So this one talks about a manufacturer makes 2 products, A and B, each of which is processed in 2 departments, production and finishing. Each unit of product A takes 3 hours to create and 6 hours to finish, whereas each unit of product B takes 5 hours to create and 2 hours to finish. So how many units of A and B can be created and finished if 24 hours are available in each department? All right, so then part A would be sketch the feasible region relating the manufacturing of the 2 products and the number of hours of labor. And then assuming all 24 hours can be used for production, how many of each product type should the manufacturer produce? And then we have our additional questions. The first thing we want to do is figure out what our inequalities are going to look like. So while you guys take a few minutes, I'm going to upload this file for you to download as well. All right.
So I'm assuming we're going to enter our constraints that we think in the...
Yes, if you will, enter your constraints in.
Do we want to use A and B, or do you want us to use X and Y? Makes more sense.
We probably want to use X and Y. So we'll use X for A and then Y for B. Just take a couple minutes. Well, I'm going to give you guys 2 of the constraints. We know that the products have to be both either greater than or equal to 0.
And that's
right?
those are constraints that I think students often forget because they're
Yes.
not, specific out there. So that's a really great conversation to have with kids is, what are some assumptions here? You can't have negative production. So.
Right. So I'm going to go ahead and enter those. So the first one, I'm going to say X is greater than or equal to. So you will notice that we can graph X inequalities as well as X equals equations very easily without having to go through too many different menus.
So that was just type, right? Again.
Yep, so that's once again going into type, pressing F6, and then if you didn't see me catch, there's another F6 arrow, and then that takes you to your X inequalities.
Nice.
All right, so now I'm going to arrow through again. And so we know we said X, so our A products have to be greater than or equal to 0, and our B products have to be greater than or equal to 0 as well. So I'm going to type that in. You'll notice as we change each of the inequalities, the screen does bump up a little bit, but all those inequalities are still there. It just kind of, moves the screen a little bit so you're not as confused with what you've already entered to kind of clear the space a little bit. All right, Karen, thank you very much. So she has
what it is though?
3x, not 5y. Is it 5?
Did I do that wrong?
Nope, you're right. There was just a typo on my page.
Okay, I guess here's what my question was.
3x plus 5.
It says, is it 24 hours total or each department's doing 24? That's where I guess I'm.
Yes, it says each department has 24.
Okay, all right, then that makes sense.
Yeah. So 3 hours and 5 hours to do the production, right? And then 6 hours and 2 hours to finish. So 3x plus 2y is, or 5y is less than 24, or less than or equal to 24, and then 5x plus, was actually, no.
Is it 2y?
6x plus 2y. That's what it was, yes.
Thank you, Tom.
Yes. So thank you guys for Tom, Karen, and Tom for helping out with that. Yep. All right. So this is once again where we would have to enter our fractions if we didn't want to do all the math or force the kids. But I mean, if you wanted to, you could have them enter in the equations, you know, in their simplified form where you have, you know, a slope with the x and then, you know, your y-intercept. But just to make our life a little bit easier today, we're going to not do that. So let's make sure that my inequality is set up correctly. So that is not the right inequality. So I'm going to go back to type and I'm going to convert it. So what should be y is less than or equal to. All right, so the first one is production. So it is, I'm going to actually use the keyboard on my computer because the buttons are not, sometimes a little bit finicky. So 24 minus 3x x. And then once again, I'm using the ABC button to represent a fraction. 5. I could also use the division sign if I wanted to, but I like using it to remind the students that we're dealing with like a fraction there. All right, and then 24 minus 6x all over 2. All right. And now if I go and try to graph this,
Probably gonna have to change our window.
Probably gonna change my view window. So let's go ahead and just go there to change it to kind of set it up to the window that we would want. So I'm gonna press Shift F3 so I can go to my view window. So with our previous one, this is kind of what we had, but let's go ahead and I'm gonna cheat just a little bit and set it up based on what I think is going to happen, and we can adjust it from there.
So here's my question, you know, I'll just throw it out there to those of you. I know 0 is the min, right, for both of them, but if you want to actually see, I tend to always put it like a negative one. I don't know why. Maybe it does, just so they can see the axes and I find
and sometimes that'll help because that also pushes it up so that so it looks a little bit easier to see. So now I'm done changing my view window, so I'm going to press exit, and now I'm going to press F6 to draw. And
yeah, see, I think having the negative makes you see a little bit
that definitely helped a little bit better. So now we can also, you know, zoom in a little bit more because you know that there's nothing going on over here. But it is kind of nice to see the axes. And, you know, Tom agreed with you on that one, so that's great.
Thank you, Tom. Well, because, I mean, if you think in linear programming, the solutions, the optimum solutions are the vertices. And if you don't have, they don't see that 0, 0.
Right.
It's technically a solution, but not the optimal, obviously. But,
yeah, absolutely. So yeah, so since this is a linear programming problem or question, we know that this vertex here where those two inequalities intersect, you know, is one possible solution, one right here. So this one we have 4 because we have a little bit of a
So if students are having to test that, which they are, because they're going to have to answer the questions, like what do they do? How do they find those points on the graph?
So once again, we can go to GSolve.
Okay.
And then go to intersect. And then we would just have to rotate through and choose all our different types and make sure we hit all of them. And then they just have to jot them all down. on their own pieces of paper or, you know, in their activity or whatever.
Right. So trace wouldn't work? I guess not.
Trace, you could probably use trace, but it just, intersection
it would take longer.
Trace would take definitely much longer. Intersection would just be more accurate as well.
Right.
Just based on where you're doing. So let's do, oh, and that is interesting. I forgot about that. Thank you for asking, because our first equation, remember, was an x is greater than or equal to 0. And because we're dealing mostly with y's, you can't necessarily find the intersection between the first and the second.
Interesting. Because it's an x.
Because it's an x, yeah. That is kind of one of the downsides to our technology, or, you know. But so let's find y2 and y3. Well, so that's, we know, is not part of the optimal solution. So then let's go to intersection of y3 and y4. So we know that's one of our options. And then what we're probably going to have to do is find the roots and the y-intercepts of the other equations, because we know they cross at the axes.
Okay. So that's, I mean,
that's definitely a good question
for kids.
Yeah. So let's find, so we know that this is a y4 inequality, so let's find the root of that inequality. So there would be one solution down here. Yeah. And then the other one is crosses the y-axis, so that would be a y-intercept. So if we go to GSolve, that's F4, the y-intercept of y3. And then based on looking at the graph, we would have to also remember that 0, 0 is another option as well.
Yeah, well, that's probably not the optimal, but
right.
That means you're not doing anything.
Yes.
Right?
It's a solution, but definitely not.
The importance of understanding the context.
Yes. And so that's something else to think about too. So the way, so those are the basic questions in these investigations, and then most of the investigation you'll see is actually going to be the sample solutions. So walking through some of, you know, the thinking that we want students to go through as well. A little bit more in depth than like the other ones, and maybe how to set up the, you know, the graphs themselves as well.
And you'll notice that the fostering series is based on the color CG50.
Correct.
No, it's CG.
It's a CG, yeah, the previous model was a CG10, and the new one is the CG50. So yes, the two colors. So you can see that we use the exact same question, we just happen to be graphing in color instead.
But that's a nice comparison if you go back to your, no, stay on the page you were just on, sorry. What do you mean? You don't know what I'm thinking? But go back to your, on your calculator, just to show the difference of the way fractions are in all the other graphing models except the 9750G2, I believe. They all are standard notation. So that's just the main difference here. You actually see the fraction.
Correct. Yeah.
But our new 9750G3 is going to have that.
That's correct. We are launching a new model very shortly. So it's the 9750G3, and we've upgraded basically this model to include this natural display, so standard form display of fractions, and just in general.
Among other things, yeah.
Yeah. So definitely check it out on our website. All right. So that's basically it. So what I am going to now share is this activity list. So we went through crafting money, we went through maximizing space, and we also went through manufacturing on this page. So we went through B and E. Kind of took a look at those two activities. But these are all the activities that I could find in our resources that were written activities or investigations that dealt with graphing inequalities and linear programming. So you can see we have some of these. And they are all available. Let me pull up that website real quick on our Casio Education resources page, our activity page. So if you go to casioeducation.com, and then the easiest way is to go to our remote learning page, And when you scroll down, it'll take you to our math activities. So on that PDF, you'll notice this one is for the 9750G2 for high school, and then I also gave you page numbers here. Because the way our activities are set up, if you go to the 9750G2 and you go to high school, you'll get, I think it was 600, yeah, 665 activities altogether, which I know is a lot. So we went through and put together a table of contents. And this is just the easiest way we could figure out to do this without taking up too much room and having you do too much searching. So the name of the activities are all alphabetical order, and then as well as a quick content focus here, and then the page numbers that activity falls under. So you'll see for Crafty Money, this is from the Algebra 1 book. It's on linear programming. It starts at page 97. So if you're using this view, or if you're in your PDF, you can just type in page 97 and hit enter and go to it. So in like a web browser, if you kind of hover to the top of the PDF, you'll see that you can highlight the first page and you can change that. So you can actually change it to 97 and then hit enter, and it'll automatically jump down to those activities there, the activity that you're looking for. All right. So what we will do is, I have all the page numbers written out, but I will also, in the next couple of minutes, upload each of these individual activities to you guys through this chat panel since you guys are here. And while I'm doing that, I'm going to let Karen kind of wrap up the webinar, unless there are any additional questions on, linear programming or inequalities or anything functionality-wise you guys wanted to see on the 9750G2.
Okay, but I don't have the PowerPoint, Amy, so there
I'm doing it.
Get going. All right, so we have webinars every Thursday, and we kind of alternate between ClassPad.net, which is our free web-based math software, and then every 2 weeks we do calculators. So here's the ones that are upcoming, and you can sign up. We'd love to have you join us for those as well. And Amy.
Yes, sorry.
You might have to.
Is this where you wanted to go next?
Yes. So here's all of our website links. I did want to actually, if I can bring it up real quick. Our YouTube site has.
Let me stop sharing and give you the screen then. Because actually that was something I was going to look up.
Yeah, I did a whole, so I write the Casio blog, and I've been doing mini lessons every day where I'm sharing lessons for ClassPad each week and also lessons for the calculators. And I did a whole week of just linear programming on the calculators. And so I'm trying to share my screen, and of course there's too much going on right now. There we go. Let's see, which screen do I want? There it is. Hopefully everyone can see that. Can everyone see that? Yes. So this is our YouTube site for the hardware, and we have playlists. And one of them is the mini math lessons right here. Mm-hmm. And you'll see that there's several that are on linear programming. So that's another place, because I've actually gone through a lot of the lessons that Amy is sharing with you and walked through all of the different ways to do them and all the steps and stuff. So that's another place to get some resources specifically on linear programming. But the whole website has a lot of different resources on our hardware and the different ways to use them. So the playlists are a great way to, if you're looking for a specific model, we have them, each model is here with resources, and we're updating those, pretty frequently.
All right, we had a question about emails. So we will actually be sending a follow-up email letting you guys know about this recorded webinar, which is going to end up here, as Karen said, under the webinar playlist, which I don't see right now, but it's up there.
Oh, yes, sorry. Where is it?
There it is. So this is where you can find the webinars, the playlist of the webinars, and we'll upload that. But we will also include a contact email. But if you have any questions, I'm going to type another email address into here that will automatically come to us. And so if you have any additional questions as you're working, this is an email address you can use to contact Karen and I.
Amy, do you want to share the links again? Sorry.
Yes, I can do that. So I'm not going to make this full screen, but the email address is here as well. So if you have any additional questions, it's calctraining@casio.com. But here's also our Facebook, Twitter, and Instagram pages, as well as that YouTube site to get to all the videos that we have uploaded already.
And this webinar, I post them usually by tomorrow morning sometime. So
yes.
This will be up if you need to reference it or pass it on to somebody else.
Yep. Additionally, we can offer you guys a certificate of attendance for those of you that are on here tonight with us. So if you need that, when we send out the email tomorrow, our follow-up email, you can let us know whether you need a certificate of attendance or not, that you can use towards your professional development hours with your school or district.
It just basically says that you attended an hour of professional learning training.
Yes. Yep. All right. If there aren't any more questions, that's about it for me tonight. A little bit shorter than our normal, but we were able to get through everything. So
it's always nice to end early.
Yeah.
Especially on a Thursday night.
Yep.
Thank you, everyone, for joining us. We really appreciate all your time and questions and listening and participating.
Yes. And also on that PDF that I will send out that has the list of all the webinar activities, I have a couple of additional resources down here as well, that links that you can go to. So the remote learning link will take you to how to download the emulator software that I was using, which does come with a 90-day trial. I think I forgot to mention that at the beginning. So you can download and use this for 90 days for free first. And then jump to purchasing. So, all right. Thank you guys so much for joining us. Hopefully we see you on a future webinar.
We're going to stop talking, but I am going to leave it open for a little bit so that everyone can, who's interested in downloading all the single PDFs, can do that.
Yes.